So, what makes this challenging chapter a lot of times is it's that there's a lot of like formulas or identities that we're using, and it's our job to be able to pick out the one that is going to work for the given situation. And that's an area where people sometimes find some difficulties. And what we're doing is we're reaching a little bit beyond our families. We're going to start seeing how to figure out the exact values and work through and manipulate the sine, cosine, and tangent. We're going to restrict it to, we're going to set cosecant and secant for a side for, or on the side for a little bit. But we're going to be using some different identities to be able to find some actual values of others. So to start, we're going to introduce what these identities look like, and they're just formulas. And then we're going to work through how to recognize what's being used, how to recognize the identity in the given situation, and then we're actually going to apply the identity. So we've got a couple steps that we're going to be going through today. Before I start writing these many, many identities, I want you to know that you do not have to memorize them. You do not have to memorize them, you do not have to memorize them, and you do not have to memorize them. And I can guarantee at least one person in this class is going to ask me, do I have to memorize these? Okay, you don't, all right? You do not. You will get a sheet, and in fact, it looks like this. And I'm going to show you all of them. Here's where we start. There's our sum and difference, double identity. Look at what I'm talking about. Yeah, did you just throw up a little bit? Yeah, this is the chapter. Yeah, these are all of them. And again, you do not have to memorize them. You just need to be able to recognize which one would be used in the given situation and then be able to apply it. All right? You'll get this. All right? We start slow, and today is sum and difference identities. And again, we are restricting it to sine, cosine, and tangent. And so we will start with, oh, I have a bloody finger from a hangnail. Sorry. Okay. We'll start with the sine sum. The variables I use can be changed. They are just placeholders to show that I have two different angles that I'm adding together. So I'm going to use alpha and beta because that is what your note sheet uses, okay? But again, you can use X and Y, you can use A and B, but your note sheet uses alpha and beta, so that's what I'm using. Let's do this a little practice. Alpha, are you with me? It's like a fish. I start up at the top, I go around, alpha. That's it. Beta, it's a B, but we start at the bottom and make our beta. Not fancy. It sort of looks like a crooked heart almost to me. But alpha and beta. If you're like, man, I hate those, put A and B. I don't care. Any variable you want, X and Y. I'm just using alpha and beta again because that's what's on your note sheet. So the sine sum, and I know it's a sum because there's a plus between it, is the sine of alpha, the cosine of beta, plus the cosine of alpha, sine of beta. And what this means is, if I am taking the sine of two angles added together, I can't just do the sine of the first angle plus the sine of the second angle. It doesn't work that way because that's not how trig works when we do these circular moves and with our identities. And so this is how I expand it out to figure out what that value is. The sine difference is very similar, except guess what? Minus. That's it. So sine alpha cosine beta minus cosine alpha sine beta. So that's our sine sum and sine difference. It would be lovely if all of them kind of followed the same thing, but they don't. And I will actually post a video if you're interested in the whole process of how they got this. You can take your time and look, but most people give the response that Courtney gave. No thanks. Don't care. Okay, so the cosine alpha plus beta is cosine alpha cosine beta minus, no, I did not make a mistake, sine alpha sine beta. In the cosine sum identity, we actually subtract the two products. So cosine alpha, cosine beta, minus sine alpha, sine beta. And then the cosine alpha minus beta, or the difference, is exactly the same except plus. And then lastly, the tangent. The tangent alpha plus beta is the tangent alpha plus the tangent beta over 1 minus tangent alpha times tangent beta. And they look really complicated, but again, I'm going to show you how we use them. And once we get kind of into it, it works its way through mathematically pretty nicely. But people get scared. I think that's the big thing. Tangent difference is the tangent alpha minus tangent beta over 1 plus tangent alpha tangent beta. Okay. So those are the identities, the 6 identities that we're going to focus on today. And for starters, like I said, I want to first make sure that we can recognize, that we open our eyes, because really one of the best things you can do when you do math is be observant. Pay attention to patterns, pay attention to things that are going on around you. And so we're going to start by being observant and trying to figure out which of the identities is being used. And that goes pretty quickly again to, like I said before, here we are. I think I keep saying again a lot, sorry. The first one I think is pretty self-explanatory. I know that this is the tangent, one of the tangent ones, and I know that because it has tangent in it. And this one says it is the tangent of negative 6 theta plus the tangent of negative 4 theta over 1 minus the tangent of negative 6 theta times the tangent of negative 4 theta. And what I need to do is recognize which identity this is. And again, I recognize that this is one of the tangent ones. And then I look very closely at it, and I figure out that it's the sum. And I know that because when I look back at my tangent sum, it's plus on the top and minus on the bottom. And that's what this one is, plus on the top and minus on the bottom. So it's my tangent sum. Now, what is it the sum of? It's the sum of my first angle alpha and my second angle beta. And on the bottom, there's alpha and beta again. So alpha is negative 6 theta, and beta is negative 4 theta. And yes, it shows up in 2 places, but when I'm taking it back to the original identity, I don't need to write it. So I am taking the expanded form and compressing it into the original identity form. And because these have the same variable in it, theta, I can combine like terms and finalize my answer, and I'm done there. I can't figure this out because I don't have one of the families that I know here. In fact, I don't even know what theta is. Theta and pi are not interchangeable. This is not like the tangent of negative 10 pi. This is the tangent of negative 10 theta, and I do not have a theta family to work with. So I stop here. There's my answer. So again, for starters, recognize what it is. Work backwards, simplify if you can. We'll take it one step further on the next few problems when we get down to 5 and 6. So let's move on to our next one. When it comes to the sine and cosine ones, you have to pay a little bit more attention because they both have sine and cosine in them. So number 2, I know is the sine, one of the sine identities. How do I know it's one of the sine identities? It starts with sine. That's one dead giveaway because the cosine ones start with cosine. And also the sine one has sine cosine and cosine sine. It has them mixed together. So this is the sine. And is this the sine sum or the sine difference? Difference, so it's minus. What are my 2 angles? 1 theta and 3 theta. Yep. I'm going to do the 3 theta first because that was the one that showed up first. So that must be alpha. And then the 1 theta is the one that shows second. I don't need to put the 1 there, but I do know it's there. What is 3 theta minus 1 theta? 2 theta is my answer. All right. I'm not going to start the talking. I'm going to let you guys start the talking. What do I got going on here? Cosine. I heard some indifference, and then I heard somebody correct themselves. Okay. And then I have my angles. Which one goes first? 3 theta plus 5 theta. And there we are. And so I feel like you guys are picking up what I'm laying down here, yes? What do I have for number 4? Cosine difference, yep. And again, I put my angles in there. So that's negative 5 theta minus negative 6 theta. And this works just like any other adding and subtracting that we've ever done. Minus a negative is like plus a positive, and so I end up with the cosine of 1 theta, which I can just write as theta. And when we're doing problems like these 4, like these first 4 that we did, where we're just recognizing, the only reason that I'm having you do this is because I want you to be able to recognize which identity you're using. We can't do anything, we can't do any solving, but when I get down to the next few, when I actually have pi's in there, I actually have real angles in there and not like variables for angles. I have real angles. If you do it right, you should end up with one of the families that we know. So I'm going to go through that same concept on number 5. I want to figure out which identity I'm using, put my angles in, and then see if I can evaluate it. All right? So this is the sine sum. Agreed? Okay. My 2 angles are 17 pi over 18 and 7 pi over 18. So 17 pi over 18 and 7 pi over 18. And I can combine those because they're just fractions and they have common denominators, and so 17 plus 7 is 24 pi over 18. We don't have a pi over 18 family, but I can simplify this. I can divide the top and the bottom by 6, and that leaves me with 4 pi over 3. Again, if you do it right, you will know, because you will get something that we know or something that we've seen. If you get something that we have never seen before, go back and check your math. Maybe you picked the wrong formula, maybe you picked the wrong sign, maybe you didn't simplify all the way. But what is the sine of pi over 3? Well, 4 pi over 3. I know that the sign in the pi over 3 family is square root of 3 over 2, right? Good? Same thing? I almost said, yeah. And then I also know that I'm in the third quadrant and the sign is negative there. Third. Just bigger than 1. Good? Okay. And so that's what I'm looking for on these problems. All right. I know I have the cosine one next. Cosine's a little joker. That's why I like cosine. Full of personality. Puts a plus in there, but it's really minus. Psych. So that's the cosine difference. 10 pi over 9 minus 13 pi over 36. And I need a common denominator, or I need a calculator that does fractions. So this is the cosine of 40 pi over 36 minus 13 pi over 36. And again, if you are not great at fractions, that's not what we're learning here. So make sure you are a really good friend with your calculator. So I have here the cosine of 27 pi over 36, or the cosine of, divide the top and the bottom by 9, 3 pi over 4. And that is second quadrant pi over 4 cosine. You guys feeling quick on those? Getting better? Okay. I would like you guys to try 7 and 8. I'm going to pause the camera, freeze it. I want you guys to see if you can do I'll try to pause it. And then we're going to get to the real work. This first part is just kind of getting comfortable with everything. Mouse, where are you? Oh, thank you. Thank you. Anybody question? Anybody concern? Feeling okay? Okay, so we see these 6 identities. We know how to transfer from the expanded version of the identity back to the condensed version of the identity. Again, this is like going from 2 plus 1 is 3. They're the same thing, it's just a different way of writing that same exact thing. Now, I am going to take it the other way. I am going to use this identity to find a sum, to expand it into families that we know, and then allow me to evaluate a family that I don't know. We are going to stick strictly, yes?
How did you get 0?
Oh, 3 pi over 2? Did you get 3 pi over 2?
Yeah.
Okay, so 3 pi over 2 is the y-axis down below. Good?
Yep.
Enough said? All right. All right, we are only going to stick with pi over 12, just because I want you guys to get your feet a little bit wet here, all right? If you move on in math, not necessarily completely in calculus, you'll use some identities in calculus, but if you move on in math, you may find that you dive into this a little bit more deeply, but we're going to stick with the family of 12. And when I stick with the family of 12, that means I don't have a whole lot that I have to remember. But I want to rewrite this sign as a sum or a difference of the families that I know. That means pi, pi over 2, pi over 3, pi over 4, pi over 6. All right? We're going to focus on the pi over 3, pi over 4, pi over 6 family. And you might be thinking, okay, that's great, but it's pi over 3, pi over 4, pi over 6. Well, what I'm going to do is be the manipulator that I am, and I'm going to force pi over 3 to be something over 12. Good? Multiply the top and the bottom by 4, and I'm going to do the same with pi over 4. And I'm going to do the same with pi over 6. And then lo and behold, I found what I needed. If I add 3 pi over 12 plus 2 pi over 12, I get 5 pi over 12. So that's what's going to go here. 3 pi over 12 plus 2 pi over 12. Not necessarily in that order because addition doesn't matter. Okay? So this is my start. Well, I want to expand this, but I want to expand it with things that I know. So I wrote it over 12 so that I could break it down into a sum. But really what I'm working with, my two angles are 3 pi over 12 is pi over 4 plus 2 pi over 12 is pi over 6. So now I have my alpha and my beta. And I'm going to plug those into the sine sum, and then I'm going to work my way through and evaluate it. So the sine sum says it is the sine of alpha times the cosine of beta plus the cosine of alpha, times the sine of beta. This is off to the side here. I don't want that to blend in. The hard work is done. What is the sine of pi over 4? Square root of 2 over 2. What's the cosine of pi over 6? What's the cosine of pi over 4? And the sine of pi over 6? Great. I don't know if you remember this, but way back in chapter 2, we did some problems that were very similar to this. These are just numbers, and now I need to multiply them and simplify. This is the square root of 2 over 4 plus the square root of 6 over 4, or better than that, the square root of 2 plus the square root of 6, all over 4. And that is my final answer on that problem. The pi over 12, just like pi over 3, pi over 4, pi over 6, repeats its values, it just changes quadrants. So as if I have a first quadrant value, which this is, it's less than half pi, I know that it's going to be a positive number because sine is positive in the first quadrant. Yes?
Or like the cosine of pi over 6,
Yep.
isn't it square root?
Oh, we have this backwards. Thank you. You should yell at me sooner. I just listen to people and then this one's 1/2, right? Thank you. So that's square root of 2, which changes this to the square root of 6 and the square root of 2. So it just changed that around. Thank you, thank you. Sorry for that. Are we good? Are we better? Are we too damaged? You won't heal from this? Sorry. Okay. Again, what I was trying to say was that you're going to see answers like this all the time. And in fact, anytime you do a sine or a cosine pi over 12 family, it is going to be some variation of this. Square root of 6 plus the square root of 2 over 4, square root of 6 minus the square root of 2 over 4, negative square root of 6 plus the square root of 2 over 4, square root of 2 plus or minus the square, but it's always going to be the same, all right? It will be some variation of this. Sine and cosine always. So if you get something like the square root of 3 plus 7 over 8, you know you did something wrong. If you get an answer 2, You did something wrong. Your answers will always, always be in this form. So watch out for that. Tangent is a little bit different, and that we're going to do next. So tangent of pi over 12. When you set these up, there are instances where you could do multiple things. I could do 4 pi over 12 minus 3 pi over 12, that would give me 1 pi over 12. Or I could do 3 pi over 12 minus 2 pi over 12, and that would give me 1 pi over 12. It doesn't matter which one you use, you will get the right answer as long as you do your math correct. I'm going to go with the first one I said. And the reason is, so I'm going to rewrite it as the tangent of 4 pi over 12 minus 3 pi over 12. And the reason that I'm doing it this way is because I remember from doing this so many times that the pi over 3 family tangent is the square root of 3, and the pi over 6 family tangent is the square root of 3 over 3. And the square root of 3 is easier for me to work with. And that's something that you get and learn with time. Do you have to memorize that? No, but this is why I always, if possible, pick a pi over 3 family when I'm dealing with tangent. All right? It's not like it can't be done the other way, and we're going to go ahead and do it the other way, but if I can avoid it, I will. All right, so what I'm evaluating is the tangent of, that reduces down to pi over 3, minus pi over 4. And so now I'm going to go ahead and put it into the identity. The tangent difference is the tangent of alpha minus the tangent of beta over 1 plus the tangent of alpha times the tangent of beta. And so in our last chapter, we learned how to evaluate the tangent. And it is sine over cosine. And so off to the side, you may need to do this. The tangent of pi over 3 is sine over cosine, so square root of 3 over 2 over 1/2, or the square root of 3. If you have them memorized, then just write down what you remember. So that's the square root of 3 minus. How many have the tangent of pi over 4 memorized? You guys know it on sight, no thought. What is the tangent of pi over 4? 1, because that's when the sine and the cosine are the same. And then this is 1 minus the square root of 3 times 1. Or the square root of 3 minus 1 over 1 minus the square root of 3. I would love to say we can stop here. Yes?
Why is it minus if there's...
It's plus. Wow, okay. I'm tired. Sorry for my mistakes, and I'm glad you guys are so on it. Thank you. So, minus on top, plus on the bottom. All right, now I'm going to go through and rationalize my denominator, and I'm going to use a concept learned in Algebra 2 called the conjugate. Yes, did I do something else wrong? What's that? Sure. Okay, so my conjugate uses the concept of the difference of squares. And so I want to rationalize this denominator, and I don't have to use it only for the denominator. I could rationalize the numerator if I wanted to, but in these problems we're going to be rationalizing the denominator. And so I'm going to multiply the bottom by the same exact thing except for the opposite sign. And again, this is an Algebra 2 topic. Maybe you don't remember how it worked, but hopefully it'll come back to you. When I distribute, so I do the square root of 3 times 1, the square root of 3 times 1, and then I do the square root of 3 times negative square root of 3, then I do negative 1 times 1, and negative 1 times negative square root of 3. That's the top. We'll simplify it in a little bit, but I'm gonna go through that same process on the bottom. But before I go on, I wanna make sure everybody's okay. Are you all right with how I wrote that? Does that make sense? Yes?
Can't you just cancel it out?
No, no. Plus or minus between it makes that illegal. So it's gotta be an identical quantity in order to cancel it out. Yeah. On the bottom, it is 1 times 1. 1 times negative square root of 3. Square root of 3 times 1. And then square root of 3 times negative square root of 3. Do you see how the conjugate helps in the denominator get rid of the radical? What happens to those middle terms? They cancel each other out. So I'm left with, in the denominator, just negative 2. 1 minus 3. In the numerator, it is 2 square roots of 3 minus 4. Because the square roots of 3, I can't just do square root of 3 plus the square root of 3 is the square root of 6. It doesn't work that way. Square roots and powers have to do with multiplication, repeated multiplication. So adding doesn't mesh with that. So all I can say is I've got this square root of 3, I've got that square root of 3, all together I've got 2 of them. 2 square roots of 3. And then I want to go ahead and simplify, so I'm going to divide or spread out my division. This is 2 over the square root of 3 over negative 2 minus 4 over negative 2 or plus negative 4 over negative 2, I can write that as. And that leaves me with negative square root of 3 plus 2. Just like with sine and cosine, tangent will always be something in this form. The square root of 3 plus 2. 2 plus the square root of 3. Square root of 3 minus 2. 2 minus the square root of 3. Negative square root of 3 plus 2. Negative square root of 3 minus 2. Always something in that form. So watch for that. I saw some brows furrowing. Does anybody have a question about what went down there? Takes a little practice. Digging deep into those Algebra 2 skills. Let's give another one a try. No, let's not. All right. When I put myself in a position where I cannot find the angle that's there, because remember, and I'm going to write them up on the top of my page here, pi over 3 is 4 pi over 12. Pi over 4 is 3 pi over 12. And pi over 6 is 2 pi over 12. I cannot add, subtract any of these and end up with negative 7. 4 minus 3 is 1. 3 minus 4 is negative 1. 4 minus 2 is 2. 2 minus 4 is negative 2. I can't get negative 7. I could change the signs on them, but I prefer to go into the other quadrants. And so what I'm going to do is I'm going to go into quadrant 2. That's 2 pi over 3. That's 3 pi over 4. And that is 5 pi over 6. And I'm going to find those guys. Same way. Because we've used these values outside of the quadrant. So times 4 times 4, that's 8 pi over 12. And then this one is 9 pi over 12. And 10 pi over 12. And then I can use any combination of the original and the second quadrant values. And if I can't find it there, I'll go into the third quadrant. And if I can't find it there, I'll go into the fourth quadrant. And eventually I should be able to find some combination. So like I said before, there are multiple things that we could do. I can do 2 minus 9, that's negative 7. I can do 3 minus 10, that's negative 7. I could go into another quadrant and get it. Again, I could also make things negative, but I'm going to go with 3 minus 10. How does that feel? 3 minus 10? Okay. So this is the cosine of 3 pi over 12 minus 10 pi over 12. The only thing that I have to remember is when I get into a different quadrant, the signs change. Remember that in the second quadrant, it is negative positive values. This is a second quadrant angle, and when I have cosine, it's going to be negative, and when I have sine, it's going to be positive. So that's a big thing that I have to remember when I go through this. So this is the same as the cosine of pi over 4 minus 5 pi over 6. And so then I'll go back to that first page where we wrote the identities down, and I'll write this down in its expanded form. So that means I'm going to be evaluating the cosine of pi over 4 alpha times the cosine of beta, which is 5 pi over 6, plus, because crazy cosine, the sine of pi over 4 times the sine of 5 pi over 6. And then I go back to all those evaluating that we've been doing for the last 2 chapters. The cosine of pi over 4, easy peasy. The cosine of 5 pi over 6 is a second quadrant cosine, which makes it negative. The sine of pi over 4. And the sine of 5 pi over 6 is a second quadrant sine, which will stay positive. Multiply together. And I get my answer. Did it look similar to the first one that we did, the first sign that we did? Yes. Will they all look like this? Yes. All that might change is the square root of 6 and the square root of 2 and the pluses and minuses between them. We have one more that we're going to do together, and then I'm going to let you try on your own. We've got a 17 pi over 12 tangent. And this one I want to do with a pi over 6, and I'll show you why trying to avoid the pi over 6 family is a decent thing to do. All right? If you can, try it. First of all, can anybody find a combination of any angle that gets me 17 pi over 12? Because that's where we're going to start on problem number 12. Anybody get me a combination of anything that gives me 17 pi over 12? Yes, Henry.
2 pi over 3 and 3 pi over 4.
Yep, it's 8 pi over 12 and 9 pi over 12. But I really wanted to do a pi over 6 family. That was my goal. I think I'll avoid it today. We'll get into that a different time. I really want to, though.
It's okay.
It's so hard to decide. It's so hard to decide. Okay, we'll avoid it today. We'll avoid it today. Okay, because it's really easy to do this one, so why? So 8 pi over 12 plus 9 pi over 12. There we go. Which, as Henry shortened up right away, he said that was 2 pi over 3 plus 3 pi over 4. And all that I need to remember is both of these are second quadrant angles, and that's a negative positive quadrant, which means that the tangent will always be negative. So I'll expand this out. We have the tangent of 2 pi over 3 plus the tangent of 3 pi over 4 over 1 minus the tangent of 2 pi over 3 times the tangent of 3 pi over 4. Negative square root of 3 plus negative 1 over 1 minus negative square root of 3 times negative 1. Whoops. I want to clean this up a little bit. This is negative square root of 3 minus 1 over 1 minus the square root of 3. And that's minus, minus, minus the 3 negatives that I have hanging out there are going to make it positive. And then I'm going to go ahead and do the conjugate. This next step, again, won't change. I need to rationalize the denominator, and in order to do so, I want to multiply by the opposite sign between. It's using the concept of a difference of squares. And I distribute. Negative square root of 3 minus 3 minus 1 minus the square root of 3. So it was the first times the first times the last, second times the first, second times the last. And I'll go through the same process on the bottom. 1 plus the square root of 3 minus the square root of 3 minus 3. Again, first times the first, 1 times 1. 1 times the square root of 3. Square root of 3 times 1. Square root of 3 times the square root of 3. Do the cleanup. Negative 4 minus 2 square roots of 3 over negative 2. That's negative 4 over negative 2 minus 2 times the square root of 3 over negative 2, or plus negative 2 plus the square root of 3. Final answer. All right, well, I talked a lot today. I apologize. You guys ready to try this?